two topics. The first one is site analysis and setup. This one is actually for this week lecture, and the other one is trench excavation. This one. So this trench excavation is actually topic for next week. But since next week we will be having Hari Raya holiday kan, so I'm thinking we're not going to have any class lah for next week. So the topic for next week, I combine it with this week lecture lah. Okay. Okay. Okay, so our first topic for today, site analysis and setup of the construction site. Okay. Okay. So by the end of this lesson, I expect all students will be able to identify what is the setting out works. For example, like site clearing, what method used in setting out of site, and also you are able to establish the datum level of the site, like that you explain how to establish a datum level of the site. And the second one, you also must be able to identify the accommodations. So accommodation here referring to accommodation for workers, storage to keep construction materials and also equipments, and security requirements during the construction stage. And last is to describe the detailed stage of the building process. So all these lesson outcomes for today, they are related to Kosapkan number 1. Okay. Okay. Before you start with the building construction, and before you start constructing the building, what you need to do is you need to do the site analysis of the proposed area. So that is the first thing that you need to do. So this site analysis, it includes determination on the location of the project, the site and the zoning area. You have to check if there is any man-made features, is there any utilities, and so on. So that's why you need to do the site analysis. And the site analysis also, it includes determining the economical feasibility of the chosen site. For example, you need to do site investigation to identify the type of soil, the soil profile of the proposed site, and if there is any services on the site, and so on. So all these tasks, determination, soil investigation, actually it will involve cost lah. So that's why you need to do this site analysis. So what is soil profile? Because in site analysis, during the site analysis, you also must know what is the soil profile of your project site lah. Okay. So soil profile, this one is the vertical cross section of soil layers. Okay, if you see the example, the first figure, this one. Okay, the first figure, that one is the example of soil profile. Okay, it is a vertical cross section of soil layers, which you can find in your site project. Okay, so you need to obtain this information as well lah. Okay. So let's say why you need to have this information. So let's say the soil profile of your site project is not complete, meaning that you don't have the data lah for your soil profile. So since you don't have sufficient data on the type of the soil across your site, there will be risk to the construction process, such as delay in construction. Okay, delay in construction, why? Because you don't have sufficient data to decide on the type of foundation for that area. For you to decide which type of foundation suitable for that area, one important factor is the soil profile. You must do the site investigation, and also there will be an additional cost lah if you encounter weak soil on your site project. If your soil is weak soil, then you have to solve this problem before you can proceed with the construction process. Okay, so that's why the soil profile is one important information lah, that you must have during the site analysis. Okay, so insufficient soil investigation, if you don't have sufficient soil investigation, this also will cause improper foundation design. So you must remember, soil profile, soil investigation, it is important because you need to design your foundation. When you design your foundation, there are two factors that you need to know lah. One is the nature of your soil, the other one is the loading lah. Okay, so that's why you need to know information about your soil. When you when you unable to design your foundation properly, what will happen is that it will cause structural problem in the future. For example, like settlement. So you can see from the first top figure, you can see there's settlement on the building. So what happened is that the building cracking. Okay, so usually this settlement, it is caused by clay. That's why you must know the type of soil in your site project lah. Okay, usually clay, it will give problem lah. When you encounter clay soil in your project, so it will give you a problem because um, clay is highly compressible. Okay, it is highly compressible. Okay, so it will cause soil settlement. Okay, when you put loading on top of this clay soil and it is highly compressible, then it will cause settlement. So if you see from this figure, the bottom figure, okay, soil settlement, if the soil settlement is uniform, okay, number one, if the soil settlement is uniform, then there will be no crack on the building lah, because the whole building will settle uniformly. Okay, but for uneven settlement like number 2 and number 3, okay, it will cause cracking on the building because of the uneven settlement, okay, and differential settlement. Okay, so the building will cracking. Okay, so this is structural problem lah, dangerous lah if it involves structural cracking. Okay, so that's why it's very important for you to obtain all the data. You do the site analysis lah before you proceed with your construction. Okay, sometimes your proposed construction area, it is area that has been previously developed and not currently in use. So it may be potentially contaminated. So this type of site, we call it as brownfield site. That is a site that has been developed previously but not used, and it might be contaminated lah. So this type of site, we call it as brownfield site. So this is example of brownfield site, and this term also used to describe land which is previously used for industrial or commercial purpose. Okay, and because it is used for industrial or commercial, it might have pollution, including the soil contamination because of the hazardous waste. Let's say that site, your construction site previously is a site for industrial purpose. So maybe they dump chemical waste, toxic waste to the site, so it will create contamination lah. So for this type of site, what you need to do is you need to seal, you need to stabilize, and also you need to remove any contaminated ground lah, contaminated ground or toxic waste, or other toxic waste or other dangerous substance lah before you construct building on this brownfield site. Okay. So based on all this information, we can say that the main function of site analysis is actually you want to identify what is the risk, and once you identify, you need to reduce the risk. So function of site analysis is to identify and reduce risk which related with the construction lah. Okay, and this can be done by doing the investigation, and also actually you can record the site features. Okay, what is the characteristic of your site, and also you must obtain information about the soil characteristic. So by knowing, recording the site features and also soil characteristic. So by knowing this soil characteristic, it actually will help you to determine proper design of foundation and structure for that area. And once we come out with a suitable design, then easier for us to calculate cost of the foundation and structure. So that is the function of site analysis lah. Why you need to do site analysis. So who will get benefit from this site analysis? Okay, who will get benefit from this site analysis? Okay, so of course the benefit will goes to the building team lah, the owner, the architect, the consultant, the contractor. Yeah, because by doing the site analysis, okay, owner they can assess the project viability lah, whether he or she can consult where he or she can consult with the professional advisor whether it is worth to continue with the project or not. Okay. Okay, that is the first one for owner. Okay, and by doing the site analysis also, the owner, the architect, structural engineer, and contractor will be able to choose best location for the building, because they already know the condition of the site, so they will they're able to identify which is the best location for you to construct your building. Okay, and for geotechnical engineers, they will have sufficient when they have sufficient data on the site. Actually, this will help them to design suitable foundation system for the building or structure. Okay, so that is the benefit. And benefit to M&E. So M&E is mechanical and electrical engineers. Yeah, also they will be able to design service provision. So like power supply control, selection of the heating equipment, electrical, wiring, and so on lah. So this is for the M&E engineer. Meanwhile, for the design team and contractor, by knowing the site analysis, this will help them to ensure that the safe construction method can be used for that project. Okay, and meanwhile, for environmental consultant or engineers, they also can choose suitable methods to deal with the contaminants and problem materials. So that is the benefit of site analysis to the construction panel member okay, construction team. Okay. Okay, now we look into the sequence of site analysis. So this figure 2.1, sequence of site analysis. So these are all the information that you need to do when you do the site analysis. So it involves site investigation. Okay? So when you do site analysis, always involve the site investigation. So under this site investigation, it has three different stages under the site investigation. The first stage is the desktop study. The second stage is the site reconnaissance, and the third stage is ground and soil investigation. So you must do all this. You must collect all this information okay, for site investigation. So we look at the first stage, which is the desktop study. Okay, the desktop study. So desktop study, it involves you collect all documents and materials which related to your site project from the information you can collect from local and national authorities. You also can collect the documents from the museum, private companies, and research groups, and so on Okay, you must collect information about the proposed site, your site project. So this includes maps of your site project. Okay, the service drawings. Is there any aerial photograph for your site project? Public bodies, utilities, and so on. Okay, and for brownfield site, you can try to obtain the required document from the previous owner If it is, let's say, industrial area. So you try to get information from the owner, previous owner of that site. Okay. So why it is important, this desktop study? Okay. When you complete this desktop study, meaning that you collect all the documents, important documents and information, it actually can avoid unnecessary expensive ground exploration and soil tests. Okay, because site investigation actually it involve you obtain sample from your project site lah, your site project. Okay, but if you have data, if you have data, you can obtain data on the side project. Actually, it can reduce cost lah. Okay. So if you don't have any data, then you have to do the soil investigation. Okay, you have to take the soil sample lah, in order for you to identify the nature of the soil you're going to deal in your site, on your site project lah. Okay, and it also may avoid health and safety issue. Because maybe that site, your construction site is brownfield site, so you have to confirm whether it has contaminated ground or not. Okay, so that one it relate to health and safety issue lah. Okay, and before the physical investigation are carried out, you also must know the location of utilities or services, such as water. Is there any water pipe, wastewater? Is there any telephone cable, communication lines, and so on? All this you need to get lah, the information. Okay. Okay. So the information required for a desktop study. Okay. First, you have to check the ownership and legal boundary lah, of the site project. Okay. So you must know the exact location of the site boundary of your project. Usually, this data can be given by the owner, and the owner needs to provide the design team and contractor information regarding the exact location lah, and what is the site boundary. Okay. You must know the site boundary because you don't want to trespass to other area. Okay, and this need to be checked by land survey. Land survey which conducted by JUPEM or Jabatan Ukur dan Pemetaan Malaysia lah. Okay, this legal boundaries. Okay, and other legal issue that need to be determined by the owner of the legal representative, such as right of way. So if you have a map, actually the right of way you can some of the map they already allocate a right of way lah, meaning that you can construct road on that location lah, if there's right of way. Okay, right of lights. So right of support. So right of support, this one is for adjoining properties. You can check also ownership of the land and also right of the tenants lah. So these are the information that required under ownership and legal boundaries. Okay. Okay, under this desktop study also, you need to conduct investigation on the ground condition. Okay, so what is the condition of your soil on your project, site project? Okay, so the information that you need to obtain, such as soil and subsoil condition. So this soil and subsoil condition, you can obtain the information from local authority or relevant companies lah, such as JKR. So JKR is Jabatan Kerja Raya. JMG, this one is Jabatan Mineral and Geoscience, and also you can obtain information from Kumpulan Ikram. Okay, and for geological and hydrogeological maps, and photography. Okay, geological and hydrological map. So this one you can obtain the data from Jabatan Mineral and Geoscience, and actually hydrology and geology research group in FSSA. FSSA is Faculty Sumber Alam lah in UMS. They have the expertise and facility lah to obtain information about this geological and hydrogeological map. Okay, map and aerial photography also from JUPEM, and meteorological information from Jabatan Meteorologi Malaysia. So all this information you can refer to these local authorities lah. Okay. Okay. Next that you need to know is services. Okay, services. So this one also important for you to know. The utilities on the side project. So services here they includes main water, okay, sewage, surface drainage, pipe, electricity, um, broadband, and telephone cables. So So you need to contact all supplier of these services lah, to confirm position of the service, pipes and cables. Because if you don't have this information, um, when you do excavation, for example, when you do excavation on your site project, maybe you want to excavate for trench, what happen is that um, you 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 may damage the for example the water pipe lah, service of water pipe because you do the excavation. Yeah? So you have to know lah where is the exact location of these services for you to avoid or damage the utilities or services available in that area. Okay. And then from the desktop study also, you can obtain information about the contaminated land or if the area, your site project, it contains methane or not. Okay? So usually this is associated with the brownfield site lah. We already explained this brownfield site. So for this problem, we can contact local authorities such as Jabatan Alam Sekitar, okay, just Jabatan Alam Sekitar lah for help. But if needed, you can also do the extensive soil test to confirm if there is any contamination on the site lah. Okay, so this methane, it is usually found in landfill site. Okay, if your site project is a landfill, so possibly there will be methane lah. Okay, so for this one, you can contact with the local municipal council, local municipal council lah, okay, for issue of methane. Okay. Okay, next you have to determine history of your site project, whether your area has high frequency of flooding or not. Okay, so area which has high frequency of flooding, it will have high potential to cause damage to your building lah, to your property. Okay, so by doing the desktop study, you can identify what are the factors that causes the flooding lah. Usually, it is related to heavy rainfall, poor maintenance of river, water drainage, if you see on here, surface water drainage, building site on or near the floodplain, and so on lah. Okay, so you need to check if there's any history on previous flood on the site. Okay, so this one also important lah. Okay. Okay, so we finish with stage number 1, the desktop study. So after you do the desktop study, so you have all the documents, important documents with you, then you go to the second stage. So the second stage is the site investigation, site reconnaissance. Okay, so site reconnaissance, this is the visual inspection. You do a visual inspection or walk over it on your site project. Okay, and usually it should be conducted by 2 or more people, such as architect, engineer, and contractor. So from visual inspection, and when you do the visual inspection, you can observe the subsoil, the condition of the subsoil on your site project, vegetation, if there is marshy ground, sign of groundwater or flooding. You can also observe if there is irregular topography or if there is ground erosion and so on. Okay, and photographic and video survey also very helpful. So you need to have a record lah of the original condition of the site. So you can do video recording lah. Okay, in case of any dispute or claim for damage lah. Okay, it is actually a proof for you lah. So you also need to record information of the existing building structure, such as foundation of the old building, if there is any cracking or if there is any sign of movement from the nearest building. Okay, so these are all the information that you need to notice lah. You need to observe, okay, during your visual inspection. Okay, Then all maps and records, you need to assemble them, and then you compare with the findings during the walkover. So walkover lah. So meaning that all maps and information from the desk study you can compare with the findings during you do the visual inspection. Okay, so that is the second stage. And then you go for the third stage. After you do the data collection from the desk study, you do the visual inspection. Then the third stage under the site investigation is ground or soil investigation. Okay, so usually under ground and soil investigation, the detail of subsoil information that you need to obtain, such as the soil type. We already discussed kan, soil type. So soil type is very important. So meaning that under site analysis, site investigation, you must obtain information about the soil type. Why? Because the important information for soil type is the consistency or strength of the soil lah. Their strength. Okay, because the strength of soil will determine what type of foundation you're going to use for building on that site lah. Okay, you must also know the soil structure, moisture condition, and if there is any presence of roots. And to determine the nature of the subsoil below the foundation level, so we need to obtain the soil sample. You need to take the soil sample. So, but how to obtain the soil sample? How you obtain the soil sample? Okay, so there are three common methods lah, which are the trial pits. Number one is trial pits. Okay, so in this trial pits method, you excavate the ground. You excavate the ground in order for you to obtain the soil sample. So this one is a very simple method lah. You excavate the ground. Maybe you use changkul, for example. Okay, example lah. Okay, the second method you can use borehole. Okay, borehole drilling. So this is a method to get soil sample through drilling by using a machinery lah. Okay, and so here you can see the machinery which is borehole drilling. Okay, they drill the borehole to get the soil sample. So this picture, the bottom figure here, picture you can see the soil sample obtained from the borehole drilling lah. Example of the soil sample. Okay, and the third method, this one is known as window sampler or dynamic prop testing. Okay. So in the window sampler method, the soil sample is obtained by you insert the steel tube. So it has steel tubes. If you see here, this is steel tube, and this steel tube actually it comes with different diameter lah. Okay, and the length is about 1 meter, 1 meter long. They insert it into the ground using hammer, lightweight percussion hammer, and then they extract the soil sample using jack lah. Okay, so hammer, they insert the tube using hammer, and then when they extract the sample, they're using jack lah. Okay, in order for them to take out the soil sample. So the sample of soil using this method, it can be obtained to a depth of 8 meter. Okay, 8 meter. Okay, so deeper lah compared to number one. Okay, method number one, the trial pits. And this method also suitable to be used in site with restricted access, for example, like minimal disturbance and for contamination investigation. Okay, so we have three different methods how you can take soil sample from your site project. Okay. Okay, so when information has been collected from the desk study, the first stage, second stage, the site reconnaissance, and also you do the site investigation, soil investigation. So all this information must be brought together in a final report, which is performance appraisal. Okay, so the performance appraisal here, it includes the feasibility study. Okay, you have to report on the feasibility study, the environmental, and also the risk assessment on your site project. Okay, so that is about desktop asset analysis. Okay. Okay, so when we finish with site analysis and the site investigation, then the next step is you can start with the construction process. Okay, So the construction process for building, it includes site work and setting up process lah. And also you need to provide accommodation, storage and security. And also next, we will also see detailed stages in the building construction. So this is a start of the construction process after you do the site analysis. Okay, first is the site work. Okay, site work. Site work. So in the site work, it involves leveling. I believe for student from diploma lah kan, you already learn about this leveling kan in your engineering survey. Okay. So leveling, what is leveling? So leveling, it is actually a process where you determine level of the ground of your site project. So you need to determine the level lah. Okay. In order for you to do construction on your site project, you have to make sure that the okay. So this is important because it helps the surveyor to lay a ground level which they can build a building. So you need to do a leveling. Okay. So the land surveyor also, they will determine the original ground level, the OGL, the OGL, original ground level for the land for your site project, and then he or she will mark a survey pack for drain, your pipe, cable, main sewerage, and so on lah. The rod which complying with the JPS, Jabatan Pengaliran dan Saliran. Okay, so important leveling. After you do the leveling of ground, then you can proceed with the clearing the site. Okay, so in clearing site, this may involve you do demolition of existing building. So usually demolition of the existing building is done by experienced contractor lah. Okay, and also grabbing out bushes and trees. So this one you can do it by manual or you use machinery lah. For large tree, usually we ask the specialist lah to cut large tree lah, to remove the large tree. Okay, and also removal of soil to reduce level. Okay? Sometimes you need to remove the level of the soil of the original soil. This is following to building regulation C1. So according to building regulation C1, you need to remove the top 300 millimeter soil on your original ground surface. You have to remove the top 300 millimeter soil because this top 300 millimeter soil, it contain decaying vegetation. Okay, so it is necessary to remove this layer. This layer is unsuitable to build for you to build any structure on top of it. Okay, because this topsoil, it may be compressible soil, so it will cause settlement and might affect stability of the building. So according to regulation building regulation C1, topsoil 300 millimeter topsoil should be removed because we don't want to have settlement problem. Okay. So this figure, it shows the topography of the site after the clearing process. Okay, but the leveling is still not done If you see here, just a clearing. Then they remove the tree trunk, the roots. Okay, then grubbing of tree, shrub and roots. So this one, they do the site clearing using machinery. And then this one, when they want to remove the topsoil, they use the excavator. Okay, so this is another picture of earthwork operation. You can see. Okay, so after the site clearance, then the next process is setting out the site area. So first thing, you do the leveling. After leveling, you do the clearing site, and next is the setting out. Okay, in setting out the site, first you need to determine the site boundary of the construction project You must determine the site boundary. Okay, the surveyor must determine site boundary of construction area. because you want to avoid trespass to another construction area lah. It's so important. You determine the site boundary first. Okay, so let's say from this picture you can see this is the site boundary. Let's say this is the site boundary of your construction site. Okay, so after you determine the site boundary, then you can start setting out the area. When you want to do setting out of the area, you need to establish the baseline. So this is the baseline. Okay, so this baseline, um, later you can set out a reference line for the whole building. Okay, so you determine the site boundary first, then you establish the baseline. From the baseline, you can set up a reference line for the whole building. Okay, but how to do this? How to do the setting out? Okay, firstly, you need to mark baseline on the site clearly lah. You mark the baseline on the site clearly so that the line can be re-established at any time. Okay, so this baseline, this one, the baseline, this one, baseline, it is a temporary benchmark lah for you to setting out the whole building. So you can use steel tape. Use steel tape. Usually, steel tape to measure length of your area. Steel tape with length 30 meters and not stretchable type of steel tape is suitable. Okay, so steel tape for you to measure the length, and for 90-degree angle for corner. Okay, 90-degree angle corner. This one you can obtain using side square, theodolite, or building square. So all this setting out leveling actually you will learn in engineering survey lah next second year. Okay, so I'm not going to teach you in detail lah how you do the setting out. Just information, brief information on the process. Okay. Okay, and then this is start peg. So after you identify the length, the corner, then you have to mark each corner with a start peg. So this is example you can see here. Okay. And then if you want to check the right angles, whether the corner is 90-degree or not, and or if the length is correct, so you can use side square or theodolite. You can use side square or theodolite. Okay, this for double checking lah of length and angle. Okay, and then the second step is to set up profile board. Okay, after the main building line, after you set up the main building line of your building, then you need to set up profile board. Okay, so example of profile board you can see here lah. So these are the examples. Okay, profile board. Okay, where it consists of start peg here and also what is this? A board panel. This one. Okay, board panel, start peg, and also there are nail. Okay, nail is placed on top of the board panel for you to to set up the size of trench, wall, and so on. Okay. And not only you need to set up the profile board for the building area, but for any foundation, if there's a foundation wall, you also need to set up line and put the peg and profile for this structure as well. Okay, example here, if you see from the top picture, you can see this is the line mark for the trench width. If you have wall, then you have to mark the wall width on the profile board. Okay? You have to mark it. So this is your, let's say this is your wall. Okay, so you have to mark on the peg, start peg, and the profile board to make sure that that is the line for wall construction, or foundation, or trench, and so on. Okay. And then set a step, this is example side rail. So this example of setting up the profile board. If you see here, so this is the profile board lah. Okay, profile board. So the put mark on the building reference line lah. Okay. And step number 3, you need to establish datum level. Okay, datum level. So okay, so all levels in the building they are taken from a fixed point. Okay, you take a point, fixed point, which we call it as datum. Okay, so this point, it should be established after you do the setting out lah, and also you identify the related ordinance benchmark. Okay, then you establish datum level. So again, this method will be taught in the engineering survey lah. Okay, how you establish the datum level, how you measure. Okay, and there are 3 methods when you want to reduce the level of your ground, level of ground. So we have cut and fill method. So you see the figure. The first one, the top one, number 1 is cut and fill method. The second is cut method, and the third one is the fill method. So we look at the cut and fill method first. For this, this is the usual method lah, and sometimes they call it as excavation and embankment method, or cut and fill method lah. Okay, so it is a process where the excavator it will cut. Okay, let's say this is the original ground level. Okay, if they want to reduce or leveling the area so that it is uniform, so the excavator, they will cut this section, okay, and place the soil volume into the fill area. Okay, so it will create a ground terrain, okay, terrain or ground uniform ground level, usually for road, railway or canal. Okay, and the amount of cut, the cut soil, it will be equal to the amount of fill. So that is the cut and fill method. Okay. So the second method in reducing the original soil level is a cut method. So cut method, it is made when you cut the soil or earth. Okay, let's say this is the original ground level. So you cut this area. So you want to make sure the level is uniform, but it is reduced level that is uniform. Okay, so you cut the original ground level from the desired ground height. Okay, so and then you remove the cut soil, you remove. Okay, there's no fill method. Okay, only cut. So the advantage of this cut area, because you will be having undisturbed soil over the site, because you already removed the topsoil. So the final layer for you to proceed with the construction is actually undisturbed soil. So that is the benefit lah, or advantage. But the disadvantage of cut method is that you have to remove the soil. So once you remove the soil, then it will involve cost. So it will increase cost lah in your project. Okay. And the last method, fill method, this is when soil is used to fill a hole. Okay, fill a hole to a desired ground level. Let's say this is the original, you want to make it uniform, then you have to fill this area. So so this method is actually not very recommended lah. Okay, the fill area, unless a very deep foundation is needed. Okay, why? Because of the risk of settlement. When you do fill method, okay, meaning that after you fill the soil, you need to do compression lah. You need to compress the soil because we want to reduce the risk of settlement. Normally, even after you do compression, there will be settlement lah. Okay, but in acceptable value amount lah. Okay, and the amount of fill, they should not be limited. It should be limited to 600 millimeter, meaning that should not be more than 600 millimeter lah. So that is the amount of fill. Okay, so that is for fill method. Okay. Okay, so this is the example of excavation process. Okay. 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 Next, we look at the accommodation, storage, and security. Okay. Okay, the construction health, safety, and welfare regulation in 1996. If you refer to this regulation, it details many requirement lah, well-known requirement for those working in the construction sector. Okay, this one is for accommodation. You can refer to this regulation. So this includes accommodation for the construction worker. So meaning that every time you have you involved in construction, you are a contractor, you must provide accommodation to your worker lah. Okay, and according to the regulation, the contractor must provide temporary accommodation, not a permanent lah, the temporary accommodation and also facility. So this one should be in the form of comfortable room, okay, dining room, living room, and so on lah, in the construction site. Okay, so you must provide lah, okay, to your worker. And the accommodation usually it is made of sometimes they construct the accommodation using timber or timber, okay, and sometimes the contractor they provide cabins, okay, mobile caravan and so on lah. Okay, so but the important thing you must provide accommodation which is comfortable lah to your worker. Okay, and the facilities that must have in the accommodation, such as the first aid, stretcher ambulance, the first aid room, shelter, clothing, meals room, washing facility, and the sanitary facilities lah. Okay, so this is related to accommodation. Okay, so next is so this is example, but this one is proper accommodation lah to worker. So next is storage. Okay, so not only you provide accommodation to your worker, but you also need to provide storage where you keep materials, equipment, and components lah during the building construction process. Okay, so you must provide storage. So this storage, the type of storage, depends on the durability, vulnerability to damage and also to theft lah. If you want to prevent from damage or theft, then you have to provide storage with good quality lah. Okay, for example, okay, storage for cement and plaster. Usually cement and plaster they are provided in bag form lah. So this cement it must be properly keep in dry storage, which is free from the moist air. If you have cement, you have to properly store the cement, because if the cement is exposed to the surrounding air, it will cause the cement to harden. So once it's hardened, you cannot use the cement anymore. So you have to buy new one. So this will increase the cost. So storage is important for these materials. And for aggregates and sand, okay, it requires a clean, firm base. So you have to make sure that the storage for aggregate sand is a clean area, and keep separate. You keep separate different materials and grade. If you have different size of aggregates, coarse aggregates, then you have to properly store them at different area lah. Okay. And brick and blocks also need to be stacked in stable piles, and you cover it sufficiently lah. Because if you expose, for example, this is a brick and block, so you need to stack it, meaning that the brick or block it cannot directly in contact with ground lah. Okay, you need to put a stack, stable piles, and also you need to cover it sufficiently, because you don't want the brick and block to expose rain or high temperature, okay, because it will affect the properties. Okay. And number 3, security and protection. Okay, security here it defines a limit of sight, and you prevent from trespasser or thief lah. You limit the site so that outsider they cannot enter your site lah. Okay, so that is security. So how to provide this security? So it can be provided using a physical or visual barrier lah. Physical or visual barrier. So physical barrier usually is fencing lah, pagar. Okay, fencing. Okay, So security and protection, it should start at the beginning of the construction. So you have to plan properly lah. Before you start with the construction, you already erect the fence, the pagar, okay, around your construction area. Okay, and the type of fencing, what is the type of your fencing? It depends on the security, degree of security. If you want high security, then your fence should be strong lah and good quality. Okay, cost depends on also on the neighborhood and also duration of contract. Okay, and the height of the fence should not be less than 1.8 meter lah. This one at least 1.8 meter high. Okay, height of your fence. Okay, and also it should have minimum number of access, and also you should have lockable barrier. Okay, because you want to prevent thief. Okay, so that's why you need to put minimum access, and you have to lock the fence lah. Okay, and the standard fences, this one you can refer to BS 1722, that is the British standard lah. Okay, if you want to refer more information about the standard fences. Okay, so we look into some example of fencing. Okay, so this is cleft chestnut pale fencing. So actually there are many types lah. Okay, so we also have, so this is the picture, real picture of this inilah, chestnut pale fencing or timber fencing, something like that, wood fencing. So we also have this fence with concrete posts. So fence pagar with this concrete post. This one is, the post is concrete lah, concrete type. Okay, and then this is the chain link fencing lah. Okay, so this type, so this is the common one lah that you can see. Okay, so this is the example, but this one is not concrete. This one is like steel. You can see the steel post here, but the design is similar. And also we can have this cross-bordered fence. This one you can erect it near to a highway or public footpath in order to prevent from the unauthorized person okay, obtaining access to site, and also to prevent public from dust and noise. So this one is cross-bordered. So this is example. Okay, sometimes they use a steel sheeting as a okay. However, to erect this hoarding, you need to obtain permission from the local authority. So this is based on Highway Act 1890. So you cannot just erect your hoarding fence without permission. You need to get permission first. Okay. And for hoarding, there are two forms. One is the vertical hoarding, and the other type is fan hoarding. Okay, vertical hoarding and fan hoarding. So for vertical hoarding, this is the panels is cross-bordered panel, and then it is fixed to resist wind load and impact. So it can be freestanding, or you can fix it to the external wall of an existing building lah. So that is the characteristic of the vertical hoarding. For fan hoarding, this one is used to protect a person from falling object. Okay, so normally it is placed above the normal traffic height lah, and it will ensure if there any obstacle or debris falling down from the constructed building, it will be directed back towards the building. So you can see here, this is the typical arrangement of vertical hoarding. So it consists of a panel. So this is the panel, but this one is the side view, so you cannot see the panel lah. Okay, so this is the panel actually. So this one is braces. Okay, so this brace is to hold the panel so that it always in vertical alignment. Okay, so vertical hoarding also can have footwear. So meaning that public, they can walk on near the hoarding. Okay, this is footwear, and also it must have this guardrail. So that is brief description of vertical hoarding. Okay, and this is example vertical hoarding. Okay, this also, so this one is made of timber, plywood timber. This one is steel. Okay, and then for fan hoarding, Okay, this one is vertical. The first figure is vertical hoarding. This one is fan hoarding. The bottom figure, that one is the fan hoarding. So fan hoarding, as I mentioned before, it is used to prevent um, falling debris. Like let's say brick fall from the constructed building. Okay, it will not fall direct to the ground lah. Okay, it will fall on the fan hoarding here, and then from the it uh, fall from the fall to the fan hoarding, and then it will be directed back to the construction site lah. Okay, so you can see there's a hole here actually. If you see the arrangement, you can see a hole lah for the debris to be directed back to the construction building construction. Okay, so this is example of fan hoarding. Okay, this one you can see. That is the fan hoarding. Okay. Then next, last one is order of construction. Order of construction. So we look at this picture. So order of the construction, number one, you need to do excavation and timbering lah. And timbering. Every time you do excavation, trench excavation, you have to use timbering as well lah. Okay. And then stage number two, you construct foundation. Stage number three, concrete floor, construction of floor lah, concrete floor. Usually for building we use concrete floor lah. Okay. And then number four, stage number four is frame, structural frame lah. So structural frame, it can be concrete, it can be timber, or it can be steel. Depends on the type of your building. Okay, number five. Number five and number six. Okay, in some construction, after they construct structural frame, then they proceed with. But in some construction, they start with the brickwork lah, wall construction. Okay, so for actually both can be like, you can start with either roofing or the brickwork. So example here for this picture, they start with the brickwork lah, meaning the wall construction. Okay, and then after they construct the wall, and they construct roofing. Okay, and then number seven, this one you need to do internal fixtures and fitting. Okay, and stage number eight, if you need to put any insulation, you do plumbing and wiring. Okay, and the last stage, stage number 9 is painting and decoration. So that these are the construction order of construction lah. Yeah, simple process. Okay, so this one is for house lah. Okay, so okay, that's all for our first topic today lah. Okay, site analysis. This is the topic of site analysis. Okay, this is the first topic. So we take 5 to 10 minutes lah rest before we proceed with the second topic. Okay, so site analysis and setup. Okay, so we take 5 to 10 minutes rest before we proceed with our next lecture. So next week we are not going to have any lecture because of holiday. That's why I combine 2 topics for today's lecture lah. Okay. Okay, so we proceed lah with our next topic. Okay, so next topic is trench excavation. and trench excavation. Okay, so the lesson for this topic. Okay, you must be able to describe factors affecting the method of selection of the trench support system. Okay, and also you must be able to identify various types and function of the trench support system. So these are the lesson that you need to understand. Okay. So what is trench? What is trench? So this is a picture of trench. So actually, it is a type of excavation in the ground. Lah. You excavate the ground, and generally it is deeper and also narrow. So that is trench. So the purpose of excavating a trench actually is to allow installation of public utilities. Lah. So you want to install sewer, foundation, drainage, and so on. Okay, and this excavation of the trench, it can be done either by hand, manual excavation, or you use a machine. Okay, and then excavation can be classified into three types. Okay, the first one is the shallow excavation. So shallow excavation, the depth of excavation is up to 1.5 meter. Okay, and then we also have a medium excavation, where the depth of the excavation or the depth of the trench is 1.5 to 3 meter. And then for deep excavation, okay, the depth of the excavation is more than 3 meter. So these are the three classification of excavation. So it depends on the depth. Okay, 1.5, 1.5 to 3, and more than 3 meter. Okay, so we classify shallow excavation. So the first one is the shallow excavation. So we classify shallow excavation when the depth is up to 1.5 meters. So if you see from the right figure, you can see 1.5 is actually the depth is until your ni lah, okay, until your chest lah. Okay, the depth is 1.5 meter. And when you stand in the excavation trench, so the depth is actually until your chest lah. Okay, and this is actually the deepest excavation that a person can enter lah. Okay, 1.5 meter should not be more than 1.5 lah. Okay, why it is limited to 1.5 meter? Why? Okay, this 1.5 meter is the height that set for a person, so that if a collapse occur, you will not be buried any further than your waist lah. So this is your waist. So if the site of your excavation or your trench collapse, okay, it will not cover your lung, your chest here. Okay, so it's below your waist. Okay, so this is actually what we want to eliminate condition where the expansion of your lung is limited due to weight of the material. If the collapse of the soil, it cover up until your chest, okay, it is difficult for you to breathe. Okay, so actually this 1.5 meter, it gives safety lah when accident happen during excavation process. Okay, that is the reason lah why it is limited to 1.5 meter lah for a person to enter the excavation. Okay, up to 1.5 meter. But how about if the excavation deeper than 1.5 meter? What can you do? Okay, so this is example lah, more than 1.5 meter. Okay, so above your head. Okay, so what can you do? Okay, because the allow depth is 1.5 safety reason. Okay, if it is more than 1.5, what do you have to do? Okay, so if the excavation is deeper than 1.5 meters, so there are a couple of things that you should do lah before you proceed with your excavation. Okay. Okay, if the trench excavation it is, let's say it is more than 1.5 meter, then it is necessary to fix temporary timber support. Okay, temporary timber support. You need to use timber support. Okay, this is to stop side of the soil or side of the trench from collapse or falling in. Okay, so so this is if more than 1.5, then remember you need to provide timber support. So the selection of trench, okay, the selection of this trench also they depends on the type of soil. That's why in your site analysis and setup in our previous lecture, it is very important for you to do site investigation because selection of trench also it will depends on the type of soil. So you must know the condition of the site lah. Usually, trench excavation. This is one of favorite topic lah that will come out in test or exam. Okay. So selection of trench, it depends on the soil type. Okay. Soil type. Okay. For example, for granular soil. Granular soil, what is granular soil? So granular soil is soil where it has granule particles, smaller particles. So it will not cohesive lah. Okay, it will not so cohesive bind with each other. It's granular. Okay, for granular soil, usually we need support for full trench depth. Okay, so full. Okay, you need to support full the depth of your trench or depth of your excavation if you encounter with the granular soil. Why? Why full support? Because granular soil easily slide. It is less cohesive, so easily slide. So you need to provide a full support lah, to prevent from the soil side of the collapse. Okay. I thought someone try to join. Okay, so we proceed. So you need to support lah to prevent from slide from the soil side of your soil slide or collapse when you're excavating trenches in granular soil. Okay, that is for granular. How about cohesive soil? Okay, so cohesive soil meaning that the soil particles it bind to each other lah. They're cohesive, melekat. Okay, cohesive. Okay, so for cohesive soil, this one it depends lah whether it is dry or wet. Okay, so for dry cohesive soil, usually it needs support after a depth more or equal to 1.5. So less than 1.5 meter, usually you will not provide support lah. This is for cohesive dry soil. Okay, because usually if it is dry and cohesive, the possibility to collapse or slide the soil, possibility of the soil to collapse or slide is less lah. Okay, so usually less than 1.5 meter, no need to provide support. But if it is equal or more than 1.5 meter, then you need to provide support even though it is under dry condition. And for wet cohesive soil, this one, for wet cohesive soil, this one need full support. Even though it is cohesive, but since it is wet, there's a possibility to collapse. So you need to provide full support for the trench depth. Okay, so I hope you understand with this one lah. Okay, so the basic how you select or consider selection of trenches. Okay, so we look into different types of trenches. So this one trenches. Don't confuse trenches with timbering. Okay, so this is trenches, types of trenches. So number one is bedded trench. So this better trench, this is a trench which side of the excavation it is cut into slope. So you can see from the figure, the side of the excavation it is cut into slope, meaning that there is a degree here lah, because it is cut into slope. So the slope is cut at a certain angle. So the angle also they depends on types of soil. Okay. So this side, why they cut it into slope? Because it's a self-supporting lah. Okay. So this is to make the side of soil balance, yeah, and able to support its own weight lah. And this is cheap and quick method of excavation, trench excavation, especially in open ground. So this is the cheapest one lah. Okay. So you can see the suggestion of slope angle on in table 1. At the bottom, you can see the table 1. So this suggestion of slope angle, it is actually based on the type of soil. So here you can see material. So that one is actually type of soil you encountered in your project area. Okay. So for example, you can see here gravel, sand, silt, clay, and peat. So gravel and sand, this one is it fall under granular material granular, and silt, clay, and peat, this one under cohesive material. Okay. So for example, in gravel, granular soil, for example, gravel or gravel, if it is dry ground, then the angle, slope angle for dry ground is between 30 to 40 degree. If the ground is wet, then the angle reduce lah. Okay, the slope angle reduce between 10 to 30 degree because you want to prevent from collapse or slide. Okay, so this angle reduce when cohesive soil is encountered. So gravel, sand is granular. For silt, clay, and peat, they categorized under cohesive. So for dry, you can see here the slope angle reduced. Okay, so similar to the wet ground lah. Okay, so you can refer this one. Even though you can cut this better trench, depends on the slope to make it stable, but actually you can use support equipment lah. You also can use support equipment, okay, to protect worker. Usually this protection it's very important, it's very useful because you want it actually difficult to determine the safe temporary slope of the ground. You maybe this is the suggestion, the 30 to 40, but sometimes depend your soil type actually they are vary lah. It's not fixed to one type only, so it's difficult to determine the angle. So in that case, it is better for you to use support. Even though this is a better trench, you can use timber support lah, to make sure that the slope is safe. Okay. 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 The second type is trench. The second types of trenches is benching trench. Okay, for benching trench, you can see from the picture that is benching method. So in this method, the excavation is cut in a series of slope. Actually, this is not slope lah. It's like a stair design, stair design, tangga. Okay, stair design lah. Okay, it's cut in a series of slope, and each step should not be deeper than 1.5. Okay, you see here. So if the person stand in the trench, the depth should not be more than the chest, his chest lah. Okay, so the depth of the excavation is 1.5. The first stage here, the second stage also you can see. Okay, it is up to 1.5 meter lah. Okay, and also it should be set back enough. Set back enough from this one, this distance, the horizontal distance. Okay, you can see this one. This is the horizontal distance, so it should be set back enough so that if the top level, if the top level here, if it is collapsed, it will not fall into the bottom of the trench lah. It will not fall here, this area. Okay, so the distance between one trench to the top trench should be sufficient enough lah, so that when it collapses, it will not fall inside the bottom trench. Okay, so this method requires a lot more materials to be excavated. However, you don't need no shoring is required. Okay, so this is benching trench. The third method is the combination of those two method, method and benching method. So this is the third method. So this is the benching method combination. So this one also can be done. Okay, and the fourth one is shoring. Okay, so this type of support, we call it shoring. So shoring is where you use support to hold up side of the trench. This is your trench, kan? This is your trench. So you use shoring to support the side of your excavation to prevent it from collapsing. We call it shoring. So there are numerous methods of shoring. It can be permanent, can be temporary. Permanent meaning that you're not going to remove that shoring. Temporary, you have to remove lah after you complete your trench excavation process. Okay, so example of temporary technique like shoring box and sheet piling. This one we will look after this. Okay, now we look at into timbering in the trenches. Yeah, so previously the battering, the benching, that one is the types of trench. Now it's timbering in trenches. That's why I mentioned just now. Don't confuse with the trenches and timbering. Okay, types of trenches and timbering. Okay, timbering is actually a method where we need equipment to support side of your trenches lah. Okay, okay. So what is timbering? Okay, so timbering is a method to prevent your side soil against collapse. Okay, we want to prevent the side soil or side of the trenches to collapse. Although you can cut the soil into different types such as battering or benching, but in some condition, especially during the deep excavation, the side of the trench, they may collapse if the soil is not hard or compact. Okay, so timbering method is very important in trench excavation. Okay, so you must okay, use timbering support as well. Why it is important is timbering. Okay, you can see the base of importance for safety of the workers. Okay, because you want to prevent from the side of the trench collapse, no safety of the surrounding property. Okay, if there's a the nearest area, it has building, so you want to to prevent from this other problem occur when you do the trench excavation. Safety of the passerby and vehicle, and also safety of service. Safety of the public service, such as telephone cable, water pipes, electric cable, and so on. So that is the importance of timbering. So members or equipment used in timbering trenches, you can see from this figure, but not all member is shown in this figure. Okay, you can refer to books. Okay, so polling board. So this one is polling board. I circle it with the red. So this is polling board, or sometimes depends on the design lah. Sometimes it also called as sheeting. Okay, so this polling board or sheeting, it is indirect contact with your soil after you excavate. So you will put the polling board or sheeting, so it will in direct contact with soil of the trench. Okay, and usually it is arranged in vertical position. Sometimes we call it as planking. Also sometimes they call it as planking. Okay. And then sheeting. So sheeting is similar, only the design of the arrangement of the plank is different. Polling boards, sometimes it is arranged in a distance. Okay, distance between each polling board lah. This is distance, but usually for sheeting, it is like a close-bordered sheeting. But the purpose is similar lah. Okay, to prevent from the soil collapse. Okay, it will be in direct contact with the soil. The second one is walling or wells. Okay, walling. So you can see this is the walling, walling. This one, walling. So it is a component where they are attached to the trench wall. Okay, so this it will support the polling boards for sheeting lah. Walling. Okay, walling will support the polling board for sheeting. And also this one is strut. You can see here the strut. So it can be wood, it can be steel, so it depends lah on the type of materials used to produce this strut. But the function of strut is to support two walls of trench, okay, to maintain a certain distance lah between the walling. So strut, okay, they will support the wall, and also it will maintain a distance between these two walling. Bracing, so this picture is it does not shows the bracing. So bracing usually it is in diagonal bracing. There is no bracing shown in this picture lah. Okay, but bracing usually it is arranged in a diagonal pattern. Okay, and it is used between two walls to reinforce the timbering framework lah. Okay, that is bracing. And runner also we cannot see in this picture, but runner actually it is similar with the polling board lah. Similar with the polling board, but it is long and thick wooden plank. Okay, it's longer than this polling board lah. Okay, and usually it has iron shoe lah attached to the bottom edge. Okay. That is runner. So these are member lah in timbering in brief description lah of member. Okay, so we look into various methods of timbering. Okay, so we have here stay bracing, box sheeting, vertical sheeting, runners, and sheet piling. But if you refer to reference book, you will find more types of timbering method lah. But in lecture, I will show you 5 methods of timbering. Okay, the first one is stay bracing method. So this type of timbering, it is used when soil is moderately firm. So you first, before you suggest type of timbering, you have to check the soil. Okay, if the question, let's say the question tell you that okay, the soil is loose, the soil is cohesive, the soil is confirm, the soil is stiff. So based on the condition of the soil, then you select lah, you justify why you need to use this type of timbering. Okay, for the first method, stay and bracing, this method it is used when you encounter with moderately firm soil. Okay, and also let's say the situation of your project, it is given information about the excavation depth. Then if more than let's say more than 5 meter, so what type of timbering suitable? If it is less than 1.5 meter, what type of timbering is suitable? Okay, so you have to consider these two lah, the type of soil and condition of your soil, and also the excavation depth. Okay, so if the soil here is moderately firm and the excavation is not more than 2 meter, then you can use this stay bracing timbering. Okay, the polling boards, if you see from this figure, the polling board, so this is the polling board now. The polling board, they are placed on the side of the trench. Of course, they will be in contact with the soil, okay, or side of the trench, and it is kept in position with 1 or 2 strut. Okay, so this is the strut. Okay, the first picture, now figure A, is only 1 strut. Figure B, you can see there are 2 struts. So you can arrange the stay bracing design like either 1 strut or 2 strut lah. Okay, so this strut is to keep the polling board in position lah. Okay, and also because this is moderately firm soil, so the polling boards, they are placed at a distance. Okay, you see the distance between one polling board to another polling board, there is a distance. So the distance for this arrangement, this soil condition is they put is 3 to 4 meter lah. 3 to 4 meter. Okay, and also the excavation polling board, okay, Okay, I just draw it like this one. So this is, let's say this is your polling board. The 200 millimeter is the width. Yeah, 250 millimeter is the width, and the thickness is between 40 to 50 millimeter lah, something like that lah. This the shape or size of the polling board. Okay, but the arrangement, there is a distance between polling boards, which is between 3 to 4 meter, and you also can arrange 1 or 2 strata to keep the polling board in vertical position. Okay, so this is the method lah. If you encounter with from soil and the excavation is not more than 2 meter. Okay, next, the second timbering method, we call it as box sheeting method. So this type of timbering, it is normally used when we encounter loose soil. This one is loose soil. Okay, loose soil meaning that it is in a granular form lah. If you don't provide a proper support, it will collapse. Okay, and for this condition, the depth of excavation is not more than 4 meter. Okay, not more than 4 meter. So for this type, a box-like structure is made using sheeting. Okay, well, strut and bracing. Okay, so where is the, so this is the polling board. So, but if you see here, the polling board, it is arranged nearest to each other lah. Sometimes they use sheeting, meaning that there is no distance at all lah. It depends on the soil condition. Okay, and then we have this waller or walling to support the polling boards, and also the strut here. There are 2 strut for each side lah. So 1, 2, bottom, up, top, and bottom strut. Okay, in order to keep the polling board in vertical position. So this is a simple arrangement of box sheeting lah. But you have to remember loose soil and not more than 4 meter excavation depth. Okay, next is vertical sheeting method. This one is vertical sheeting method. So similar, soil condition is loose soil, meaning that the soil is in granular form lah. Okay. And this one not more than 10 meter. The previous one, if you see, this one is not more than 4 meter lah. You use box sheeting. If more than not more than 4 meter lah, but not more than 10 meter, this one you can use vertical sheeting method. So in this method, actually it is similar to box sheeting lah. As you see here, the arrangement they are similar lah, box sheeting. Okay, the type in the form of like a box lah. Okay, this one. Okay, but it is also called as double stage timbering because it is the depth is too high lah. Not more than 10 meter, but more than 4 meter. So they excavate the trench in double stage timbering. Okay, number 1, number 2. Okay, there are 2 stage of there are 2 side lah. There are 2 step of trenches. So there are 2 stage of timbering. In each stage, we use vertical sheet lah. The vertical sheet to prevent from the side of the soil to collapse because it is loose. So the sheet is the vertical sheet lah. This is the sheet. This one sheeting. This one also vertical sheeting. Okay, and then we also have this horizontal well. So this is the this one is sheeting. This is sheeting. This is the example lah. Sheeting. We also have a strut. Okay, that one strut. So this is the strut. Okay, and also bracing, but okay, bracing is not shown here lah. Okay, bracing is not shown in this picture. Okay, and usually the offset is given at 3 to 4 meter of depth. Okay, so let's say this is 4 meter. The rest, let's say it's 10 meter lah, 10 meter. So the rest is 6 meter. Okay, given to 3 to 4 lah. So this method suitable for arranging gutter pipes, water pipes in the ground at a greater depth. You can propose this method lah. Okay. So next is the runner method. Okay. Okay, this method is used when you dig a very loose soil, very loose and soft ground. So we use runner method. So it needs immediate support as the excavation progresses, meaning that during the excavation, you need to put the timbering lah. Need to put timbering to support from the soil collapse, okay, at the same time. Okay, so this system also it is similar to the vertical sheeting of the box system, except that in the place of vertical sheeting we use a runner. So this is the example of runner, because in the first picture description of the member of timbering, it is not shown. Kan? So this is a runner. This is runner. Okay. So runner, it is made of a long thick wooden sheet or plank with iron shoes. So it has iron shoes lah here. Here is the iron shoes of the runner. Okay. Okay. And then we also use strut, okay, wells. What else? Okay, strut wells. Okay, and then this runner, they are driven into the soil about 30 centimeter lah. So this is the runner method for loose and very soft soil. Okay, next is sheet piling. So this is normally used when your construction site it contain water lah. Okay. So the sheet pile, sometimes there can be wooden sheet pile and steel sheet piles, but normally is steel sheet pile lah. So the wooden sheet pile, we have wooden sheet pile, and we also have this steel lah, stainless steel sheet pile. So for wooden, usually for 10 meter excavation, for sheet pile 30 meter usually depth of excavation. Okay, this steel sheet pile also you can find it in different shapes and sizes. That one is for steel. Okay, you can see from this picture. And this sheet piling, okay, when you're going to use this sheet piling, so usually it is used in this following conditional situation, where when you excavate over a large area, so you need to excavate a very large area, so you can suggest to use sheet piling for timbering lah, to prevent site soil from collapse. Or when you excavate in loose and soft soil, also you can propose this sheet piling. Or when water there comes during excavation of soil. So when you do the excavation, suddenly there's water like groundwater, or let's say a river you want to do in river or seawater construction bridge, for example. So usually we use this steel sheet pile, sheet piling. And then when the excavation depth is more than 10 meter, and when the greater width of trench is required, so you suggest you propose this sheet piling lah. So that is the situation where you can use sheet piling. Okay, so these are all the 5 types of timbering lah that you can consider, okay, in timbering of your site trenches. Okay, but these are some information lah. This is to help you to do selection of timbering when you excavate the trenches lah. Okay. For this one, extra information. So excavation which is more than 1.5 meter deep, if it is more than 1.5 meter deep and it is in compact clay soil. So compact meaning that the soil is strong lah. It is not loose. Okay. So it is sufficient to use the open timbering system. So open timbering system is like this lah. You have this polling board. Okay. So there's interval or distance between two polling board. So for compact clay soil, the interval is around 1.8 meter lah. Okay. The set of, because there's a distance here, 1.8 is quite long lah, distance. Why? Because for compact clay soil, the site of clay, it will not fall in, okay, unless it is very wet or it has to support heavy loading. Then you need to choose different timbering method. So for compact clay soil, so you can use this one. Okay, this is a traditional system of strut between the polling boards where you space it 1.8 meter lah. Okay, so sufficient for this one. For case where the where the soil is soft, for example, your side project, it contains soft clay or sand, then you need to use more closely spaced polling board lah. This is the polling board. Between the two polling boards, the space here you need to reduce. Okay, the previous one is 1.8 meter, but this one you can reduce it to 300 millimeter lah. Okay. Because we want to prevent side of trench from falling in lah. Okay, so the third one, for dry granular or loose soil, the trench timbering, this one is suitable for you to use sheeting. So similar with the sheeting box file, that the one that we see just now. Okay, so this is a sheeting method. Okay, so you put sheeting to the whole side of your trenches lah, because you're dealing with dry granular or loose soil. So your soil usually collapse, so you use sheeting. Okay. So these are some example of cross-border trench system, because maybe this one they encounter with the granular soil, that's why they will use cross-border sheeting, but they use this one, you use timber, cross-border timber sheeting. Okay, so this is example. So we have looked into different types of trenches. Okay, we have looked into different type of trenches, excavation and timbering method. So what are the factors affecting the excavation and timbering method in construction? So it depends on the nature of soil. So before you select types of timbering, okay, you need to know the types of soil you encountered in your site project, whether it is sand, clay, or combination of sand with peat, okay, and so on lah. Okay, so this is to determine what tools required and amount of timbering needed lah. Okay, so you have to know. Okay, and then number two, purpose of excavation. Okay, you must know lah why you need to excavate the soil. Must have purpose. Whether you want to construct drainage, foundation, sewer, and so on. Because the types of excavation, or purpose of the excavation, it will determine the minimum width, what is the minimum depth, and placing of support member to provide reasonable working space within the excavation. So you must identify also what is the purpose of excavation. And then factor number 3 is the presence of groundwater. If in the presence of groundwater, you need to consider using interlocking timbering. So the cross-border timbering you use sheet timbering. Okay, pump or dewatering to remove the groundwater in the trenches before you can proceed with the construction. That one is number 3. And number 4, position or location of the excavation. So you also need to know the location in case there is a restriction or police requirements, especially when excavating in public road. Okay, and number 5, presence of large number of service, which restricts the use of machinery. If there is large number of services underground, so it's actually difficult for you to dig the soil, excavate the soil using machinery. Okay, and number 6, disposal of excavated spoil. Okay, this one also may restrict the choice of your machinery or plant use for the excavation of trenches. Okay, so there's other factor. Okay, and then proprietary trench support system. Okay, in timbering, the types of proprietary support systems such as hydraulically strutted shores and walling. The hydraulic strutted shore and walling, it can be divided into 3 types. The vertical shore, water unit, manhole breast. Okay, we also have shield and boxes and flat lining system. So this is actually the type of support system where you use this material, this equipment in timbering of your trenches. Okay, so this one, if you see here, this is strut. Yeah, if you see from previous slide, slides, we always see there must be strut in your timbering of your trenches. So the strut that can be made from timber, steel. It also can be in the form of hydraulic strut, heavy duty steel strut, and so on lah. So there are many types of strut. And then this is example of hydraulic strut for shores and walling. So you can see here, this is a vertical shore. Okay, this is a vertical shore. You can see the hydraulic strut they are used to support this vertical, this one. Okay, this is the strut. Okay, the yellow and red color. Okay, and this is the system, which is this is a waller unit. This is also, you can see the strut is used to support the waller. This one is waller. Okay, this one. This is waller. So this is strut. Strut. Okay. Then this is manhole brace. Sometimes you also can use this equipment lah in your box sheeting pile, if you still remember the types of timbering. So this one also, it use a hydraulic strut lah to form manhole. Okay, and it also use a plank material. This one is plank material to hold soil from collapse lah, but it has this strut as well. Okay, and for shield and boxes type system, so this one, it consists of two rectangular structure. Okay, this one, two rectangular, number one, number two, two rectangular structure, and it is placed in the trench. It placed in the trench to provide a safe working environment. Okay, so this one also, it is known as drag boxes, this one, or saddles. Okay, so usually this type of support system, it is designed as a safety device against collapse without the need to support the trench site. No need for you to support the trench site, so you just use this shield and boxes. They are pushed into the ground as the excavator digs out the soil between the plates. Okay, once during excavation, they excavate the soil. At the same time, they will push this shield and boxes inside the ground. So this is another picture of shield and boxes type. So you can see there's adjustable strut because depends on the width of your trench. Okay, so that's why they use this adjustable strut. And also we have this steel box here, okay, required for shield and boxes type. And last is the plate lining system. So this one, they consist of rectangular plate support. So you can see there's a plate support here, the plate support, also with the adjustable strut. Yeah? And then the plate here, they are slot in each vertical section. If you see here, this one, the plate, okay. So it is available wide variety the size up to 5 and 2.5 meter high. Okay, and this one also, they will push into the ground as the soil is excavated out between the panels. So actually they are it's quite similar with this one, the box, but this one they use a flat lining method. Okay, so that's all for today. Okay, that's all for today. Okay, I hope we finish in time. Okay, we have another 6 minutes. Okay, so okay. Okay, I will stop my presentation. So I'm going to share you the attendance. The lecture notes already uploaded at the ITEL, so you can refer to the lecture to ITEL. Okay, so for our attendance, okay, so there are two attendance for today There are two attendance that you need to mark for today, because attendance number one is for the first topic site analysis and setup for this week lecture. So this one this is for attendance one, and then for attendance number two, actually this one is for next week lecture. Okay, this one is attendance number two, so make sure you mark both attendance on this. So this one is attendance too. So make sure you mark both attendance for topic one and for topic two. Okay. So next week we are not going to have any lecture because I already covered the topic for this week. So Hmm. Apa lagi?